Hello everyone and welcome to the Cisco Support Committee. Today we present a live expert series webcast and our topic will be Jabber Service Discovery using User Data Service. Our experts joining me today, Raees Shaikh, a lead for the collaboration team in the Bangalore TAC. Raees has more than 6 years of industry experience. He focuses mainly on troubleshooting and working with various voice products including Cisco Unified Communication Manager, CUCM, Cisco Unified Border Element, Gateways, Cisco Unified SIP Proxy, and Jabber in the TAC organization. Prior to joining Cisco, he was a network engineer with Microland supporting networks for future 500 companies. He holds a Bachelor of Engineering degree in Electronics and Telecommunication from Goa University in India and holds a CCI voice certification and a CCNP routing and switching and also a Red Hat RHCE certification. Our second expert is Vasanth Kumar, a technical services engineer in the Cisco TAC, also in Bangalore. He's an expert on Cisco Unified Communication Manager and also worked on TDM gateways, Cisco Unified IM and P, Cisco Unified Border Element, SIP gateways, and integration of various other third-party products like Cisco Unified Communication Manager. He has worked as a senior engineer in the US and Canada theater and is currently supporting customers in the EMEA theater. He has been helping customers as well as Cisco partners with installation, configuration, and troubleshooting of unified communication products for more than 3 years. He holds a bachelor degree in Electronics and Communication and also a CCI in Voice and Red Hat certification. Welcome Raees and welcome Vasanth.
Thank you, Satish.
Also, in the panel we have Ashish Dua. Ashish joined Cisco in 2012 as a UC support engineer. He supports worldwide customers for Cisco Communications Manager and enjoys in-depth troubleshooting scenarios. And our second panelist, Shankar Voleti. Shankar joined Cisco in 2009 as a Unified Communication Support Engineer. He has been supporting US application products for four years. He has also handled Cisco Unified Communication Manager as well, but his main focus is UC apps. Okay, so now I'd like to briefly outline for the format for today's Expert Series webcast. Raees and Vasanth will start their presentation for the first 60 minutes of the program, and then we will dive into the live question submissions for the remainder of the event. During our live presentation, you may submit your questions to be answered by Raees, Vasanth, and the team of Cisco technical experts using the Q&A box on the right-hand side of the console. The team of technical experts are well versed in Jabber service discovery, so please begin posting your questions now to give them the best chance of answering them. And also, if you experience any technical issues, please post your questions in the chat window. We'll be asking polling questions during the webcast and we highly encourage you to participate by answering them. You may download a copy of today's presentation in PDF format using the link which will be shortly pasted in the chat window and also shown on the presentation. So let's get started with today's event. And here is the first polling question for you. And the question is, what's your comfort level in ILS implementation or troubleshooting? Option A, successfully implemented in 9x but not in 10x. Option B, I know implementation part but find it difficult while troubleshooting. Option C, successfully implemented in 9x and migrated to 10x. And the last option, that is D, I haven't done much implementation so far. So please take a moment. The poll will be open on the right-hand side of the console. So please take a moment to record your responses. This will help our experts to tailor their presentation. Okay, so while you record your responses, please make sure to submit your questions and we will answer them later in the webcast. I'd like to hand over the mic to Raees, who will start the presentation, followed by Vasanth.
Thank you, Satish. Hello, everyone. Welcome once again for today's session on service discovery using User Data Service and Communication Manager. So today first we are going to discuss the ILS networking setup, which forms the basis for User Data Service to run. And once we cover User Data Service in more detail, we will explain how different clients like the Jabber client uses UDS service to perform service discovery and register with Communication Manager, get the chat services, etc. And later we are going to discuss in the end the Expressway Edge, Well, this session is more about how how the UDS plays a part in the expressway edge solution. All right, so let's begin. The ILS Intercluster Lookup Service, it forms the basis for UDS to run upon, right? Now, what ILS enables is it enables multiple clusters to talk to each other using ILS service. Now, when we talk about ILS, it is, communication between different clusters. So, for example, you have a cluster A with 3 nodes and cluster B with 4 nodes, right? And you want them to talk to each other, and you have the ILS service running. So before they actually start talking to each other, you need to mention whether you want to have a password-based authentication, or you want these 2 clusters to have secure communication using TLS, right? Now, if you need secure communication, you need to exchange the Tomcat certificates. You can go to OS admin and use bulk certificate management, right? And you can export the certificates to an common SFTP server. And once the export is done from one of the 2 clusters, you can go and consolidate. So what happens once you click on consolidate is it is going to create a consolidated file with the certificates from both the clusters. And now you go to each cluster and import this consolidated file, right? Now that's about communication using TLS for secure communication. If you don't want to have a secure communication, then you can easily go for the password-based authentication, where it will challenge for a password, and once that challenge is authenticated, the 2 clusters can start to communicate with each other. Now, the reason why ILS was developed was initially it was developed for URI syncing in 9.x, and later in 10.x, it can also be used to perform global dial plan replication. Now, for UDS, we decided to use the existing ILS setup, and build UDS on top of it. So once the ILS network is set up, the cluster can now also talk over user data service, and we will see this in more detail in later slides. ILS is a service that is activated per server, not per cluster. Okay, and once you have the ILS service set up, the administrator can then choose to have it run only on specific servers. You don't need to necessarily run ILS on every node in the cluster. And starting from CUCM 10, it will be the ILS service on the publisher that is going to talk to the other cluster publishers using ILS. The reason is with the global dial plan replication, whatever information we receive from the remote clusters needs to be updated into the database, and that happens only from the publisher. And that's why you need to have the ILS running on the publisher. But apart from that, you can then choose to have it run either on all servers in your cluster for redundancy, or you can just have it running on 2 to 3 servers. Each CUCM cluster, now for example, you have cluster A, cluster B, and cluster C, right? Now, each cluster can either be a hub or a spoke. So when the cluster is being a hub cluster, it can talk to other hub clusters, and it can talk to a spoke cluster, whereas a spoke can only talk to its specific hub cluster. So initially, when you don't have the ILS set up, or it is not taking part in any of the existing ILS networks, the cluster will be in standalone role. So when it is in standalone role, it will never take part in any ILS network, okay? So what you got to do is you have to go to the admin page and go to advanced features and go to ILS configuration. There you can change the role either to a hub, and once you once you select the hub, it will prompt you to enter the either FQDN or IP address of another hub in the network that you're planning to join, or you can make it a spoke and give the information of its hub cluster. So the ILS network supports auto discovery. So what we mean by auto discovery is, suppose cluster A and cluster B are already forming ILS network, and both of them are hub, and now you have cluster C coming up, and you want to join the ILS network, right? So you make cluster C as hub cluster, and you only give information of cluster B, right? Once cluster C contacts cluster B will also, along with its own information, cluster B will also provide cluster A's information to cluster C, and cluster C will now communicate with cluster B as well as cluster A, forming a full mesh topology. So we're going to cover a couple of deployment scenarios. Now, in this scenario, every blue box that you see is a CUCM cluster, and the CUCM cluster is playing the role of a hub, right? So when every cluster is a hub, they all communicate with each other and they form a full mesh topology. We also have hub and spoke topology. This is more relevant in case you have an SME and you have the lead clusters. So the hub will talk to all the spoke clusters, whereas each spoke will only talk to the specific hub cluster. We also have a distributed hub and spoke topology. Like you see here, there are 3 hub clusters, and each of the hub clusters has specific spoke cluster associated to them. The ILS network is set up. The changes are pull-based. So what we mean by pull-based is each hub cluster is going to contact all the other hub clusters once its defined interval is expired. It is going to request for any updates, and once the other clusters receive the request, and if they have some updates, they are going to send those updates back to the requesting cluster, right? You can choose to set the timer. It can be between 1 minute to 24 hours. Usually customers would like to keep this like 24 hours or every 12 hours in midnight when there is not much traffic, because then it requires ILS replication, etc., and an exchange of URIs and other information. So in this scenario, if you can see, the time interval between the spoke and hub is 10 minutes, hub to hub is another 10 minutes, and hub to spoke is another 10 minutes. So any changes made on the first spoke will take a maximum of 30 minutes to reach the other spoke, the other end. Before we actually get into the polling question, I can actually give you a demo on my communication manager how to set up the ILS. You guys can see my desktop?
Yes.
All right, so you get into advanced features and then you go into ILS configuration. Now, if you actually choose to use TLS certificates, then you need to get into OS admin and use bulk certificate management and export your certificates to a common SFTP data store. And once you have exported certificates from all the clusters, from one of the clusters, you will go and click on consolidate and form a file which will include certificates from all the clusters. And then you go to each of these clusters and import the certificates, right? Once that is done, you will now come to advanced features and ILS configuration. Now, if you don't want to use, if you are using certificate exchange, then you simply click on use TLS certificates. If not, you need to set a password, and this password needs to be the same password on every other cluster that needs to form the ILS setup. All right, so once this is done, you enter the password or you use TLS certificates. You change the role now to hub cluster. So initially, this will be a standalone cluster, right? And you can either change it to hub cluster or spoke cluster. I have already changed this to hub cluster. So as soon as you click on hub cluster and change the role, you will get a pop-up something similar to this. And this is where you enter the IP address of the remote cluster, whether a hub cluster or a spoke cluster that you want to initiate the communication with, right? You want it to take part in that ILS network. Once that is done, you click on OK. And this is the timer that we spoke about. So synchronized cluster in my lab, we have it set to 1 minute, but you can set it to anything between 1 minute to 24 hours. The recommendation will be depending on the amount of traffic, which can vary between 12 hours to 24 hours. Now, the advertised route string option here is mainly for ILS URI dialing, basically for routing of URI calls, right? But if you're not using URI, then you can simply ignore this, right? Once the ILS network is set up and it is taking part, you will see some options like this below. So I have this cluster, which is a hub cluster talking to, and this cluster is the one in bold, CUCM 10 RA Shaikh, right? And this is talking to 2 other clusters. One is PCD Lab 1 and the other is Purvi cluster, All right, so once the ILS is set up, sometimes it takes some time. So, don't be in a hurry and get into the mechanics of troubleshooting, because depending on the delay between clusters, etc., it can take, in our lab, it sometimes take around, somewhere between 1 to 5 minutes to set up the ILS. So once ILS is set up, you can now go to cluster view and you can set various services. Right, you can choose to talk to the other cluster via UDS, LBM, etc. So we will cover this once we discuss UDS in more detail, and Vasanth will describe user data service in detail now.
All right. So it's interesting to see that for the polling question 2, we have got a very good response. So basically, if we look at the results here, we see that 33% users are basically not sure about what the UDS service is, but a good amount of percentage, like 17% of users, already have started reading about it and have plans to develop their own applications which will be integrated with Communications Manager. So let's get into this topic where we are going to discuss about Cisco User Data Service. The User Data Service is a new web service that was introduced in Unified Communications Manager 9.x onwards, and this is primarily designed to build web applications which can run independent of device platforms. So this actually implements a user-based model which is more of user-centric rather than device or line-centric. So if a user is owning, let's say, multiple devices, he will be able to control all the devices if there is a web application developed and it can interact with Communications Manager. So he can manage his DND settings, call forward all settings. He can set up shared lines for all devices which will be uniform. And this actually makes it more convenient to handle multiple devices. The User Data Service basically implements the RESTful Web Development API, which defines a list of standards how the web interaction between the client-side application and the web server should happen. It also defines some of the backward compatibility of the new elements that are being introduced. And it uses a very common terminology and XML format in delivering the information to and fro from the application to the server, back and forth. And in addition to all these features, the User Data Service also interacts to the web server via Secure Transport Protocol, HTTPS, and it allows user authentication in case if the user is trying to modify the settings. If you look about the user authentication process in User Data Service, we have radically changed the whole proxy rights for administrator credentials. What used to happen was when you are using an application, you used to log in using your own user ID, and in the backend, the application is configured with the admin credential, which acts as a proxy to authenticate that user and update the settings if the user is making any changes. But in User Data Service, what we do is primarily let the user log in using his own credential and manage all his devices. That again emphasizes on the user-based model that we have implemented in this particular service. So this service comes installed by default in Communication Manager 9.x and in 10.x. It's activated on all the nodes. It comes as a network service, and it can be stopped depending upon your requirement on limiting the service to a list of particular servers. But you cannot deactivate this service. So User Data Service is basically a web application which is entertained by the Tomcat server, and it allows a maximum of 40 concurrent HTTP requests which can come from the client side. And if at a certain point of time, if you have more than 40 connections coming in, what happens is the UDS actually throttles the request and sends a HTTP 503 response back with a certain timeout period. So after the timeout period, the user can again send a request, and if it's below 40 concurrent requests, it will be processed. So
one thing I would like I'd like to mention here is that, like Vasanth mentioned, UDS runs on top of Tomcat. So we don't really want to overwhelm the Tomcat with a lot of requests, and that's why we have a maximum of 40 concurrent HTTP requests entertained by the server, right? Having said that, it's a one-time process for the service discovery, which means the Jabber will be using the UDS initially just in the initial install, and then you have enter the username, because after that it is going to cache the home cluster information, right, and all the other information in its memory, and it will not do the home cluster lookup every time you shoot Jabber up, right? So it's mainly a one-time process, and that's why I think 40 concurrent HTTP requests should still be sufficient for the clients, when they're trying to register.
That's right. So UDS is not the only web service that is entertained by the Tomcat server. There are multiple, web services hosted by the Tomcat server. So the throttle limit of 40 concurrent requests is based on the load that the web server can handle. So moving on, as we discussed earlier, it allows you to manage your multiple devices based on the user model. So developer can create a web application which allows them to modify the settings of all the devices and extension consistently, so that one change which is needs to be propagated to a particular device is also propagated to rest of the devices that the user owns. So let's discuss a use case here. So what we are going to discuss now is we are going to talk about the UDS resources that needs to be used and the HTTP methods that needs to be implemented for discovering the home cluster. And once we discover the home cluster, what we will do is we will manage the user application preferences through UDS. So if you look at the request that we are sending out, it's a HTTP GET method request for cluster user resource. So what the user must know is either the user ID or the email address or the UPN, unique profile number, and that request needs to be sent to one of the call manager server running the UDS service. And the request format that needs to be sent from the client application or the browser to the web server should be of the format HTTPS : the call manager hostname or the IP address, followed by the web application CUCM-UDS, and the resource name cluster user with the parameter username equal to JDO. So basically we are looking for the home cluster for the user JDO. So let's look at this flow exactly how it's going to happen when the client sends a home cluster request. So the client actually sends a request to cluster A. So the client is configured to send the first request to the cluster A. It receives that request, identifies that the JDO user is not part of cluster A, and using ILS, it has already discovered cluster B and cluster C. So the service discovery mechanism allows to send the request to both the cluster B and cluster C. In order to avoid unnecessary traffic, if the user is not available, it basically times out. So what we are seeing here is cluster C, which does not have the user, times out with no response. However, cluster B, where the user is hosted, responds back with a URL, which basically contains the user details. So here the resource user/JDO actually gives a list of devices, extension, and configuration of that particular user. So client receives the response saying the client should talk to cluster B, which is server B2, and request for the information for the devices controlled by the user JDO. Now, the client sends a GET request to user JDO to the server B2. The server responds back with the information, and in case the client needs to modify some of the settings of the devices controlled by the user JDO, it has to use the put request. So it's basically update going into the backend of the database and changing the user preferences for those devices. So in this use case, what we are doing is we are sending a put request for user JDO, and we are enabling DND for all the devices controlled by this user. So at the end of this request, you get a response back, and then all the devices with devices are set with DND preferences. So this gives an overall picture of how a home cluster of a particular user is identified, and then how you manage the user preference.
So in essence, what it's going to do is once cluster A receives the request, it is going to do and if it understands that this end user is not its local user, it is going to do a broadcast of UDS query to the other clusters, and only the cluster which has this user configured will respond back, and cluster A will pass on that information to client. The other thing which we wanted to emphasize on is that this the UDS service uses RESTful API, so it's not necessary that it's only the Cisco client which can talk to UDS, but any any partner application can also utilize UDS to develop services which require home cluster discovery, etc.
All right. Eventually, the response that comes back for the request that we sent earlier would look like this, where the request came from dc1 ccmsub.vasanth.com for user JDO, and response contains the home cluster of that particular user, which is CS-CCM pub, and it also mentions whether the self-provisioning mode and admin provision mode is set to true or false. So once we have discussed how the user data service works, let's look into the aspect of the Jabber client, which uses the service discovery to identify the device services that the Jabber client is subscribed to and register to the corresponding servers. So let's begin with Jabber. Let's begin with Jabber client service discovery. So the client, whenever a Jabber client is launched, it is the Cisco Jabber 9.7 onwards automatically detects and locates services. How it does is it basically sends a DNS SRV request to the DNS server configured for that client machine, and it gets a response back with a list of server to which it should talk to. So this basically removes the need for the administrators to configure each client PC with the configuration, and the Jabber implementation would require only the server-side changes. It also removes the use of bootstrapped files to instruct the user or instruct the users to manually configure them. And the goal of the discovery process is to identify the primary source of authentication or the cluster where the home user is located. So in this case, we are going to discuss the flow of how a Cisco UC client or a Cisco Jabber would discover the services and register to the corresponding servers. So when a Cisco UC client is launched, it sends a DNS SRV request, gets a response back, which actually queries the UC client discovery service and it to identify the home cluster. So this discovery service further sends the request through cross-cluster communication to the peer cluster. So the peer cluster responds back with the home cluster URL of that particular end user, which is then cascaded down to the Cisco UC client. Once the Cisco UC client receives that URL, it sends a request requesting for the device name and the configuration retrieval path or the URL with the user ID, credentials, and the client type. Once the home cluster authenticates the user with the credential that has been provided, it sends the TFTP service on the home cluster, pushes the configuration to the UC client, which includes all the service profile and the DN preferences, etc. to the UC client, and then subsequently the UC client registers with the home cluster. Once it is registered, based on the service profile configuration of that particular user, it registers with various services including voicemail, conferencing, or IMN presence. So let's look at how the Jabber SRV query is actually being sent to the DNS server. So when you are trying to log in for the first time, the Jabber user needs to enter his user ID or the email address, which contains the example.com, in this case portion is taken as the domain name. So when the Jabber has to send the DNS SRV query, what it does is it appends that information to _Cisco-UDS._TCP, and it waits for the response from the DNS server. So once the DNS server responds back with the communication manager to which it needs to talk to, it then further communicates with that CUCM server and further goes ahead with service discovery. And this is valid for Call Manager 9.0 onwards. For pre 9.0 versions, what it used to do is it appends the same domain name to a different SRV record, which is _cuplogin._TCP. Please note that this is only a one-time process. So this happens when the client logs into the Jabber for the first time. Once the client has logged in and the DNS SRV request is resolved by the DNS server, the client caches that information and the subsequent requests are directly sent to the response that has been cached by the application. So let's look at the 9.6 onward sign-in flow. The user has to enter his email address, which contains a user ID followed by the domain name. It sends a DNS SRV request, and once it gets a response, you will see a password request. Once password is entered and the home cluster is discovered and the user is validated, all the services for that particular client is identified, and it goes and registers for those services. So let's look at the overall service discovery requirement and the configuration that needs to be done to achieve this. So all the administrative provisioning on UC client is done on CUCM from 9.x onwards. So you need to set up a service profile which dictates the various services that the UC client can register to. So it's more of a group focused rather than user-based preferences. So it supports different clients like CIPC, cookie, Jabber, web clients, etc. And it also supports different deployment models, which includes, let's say the user is only allowed for instant messaging, or user can control his desk phone, or if he has full UC control. So from Cisco Jabber 9.6 onwards, discovery service has been turned on by default. So therefore, the client always queries for SRV record, and if it's not able to find the SRV record, it will show up an error, and you would need to set the configuration manually. There are install switches available during the install time where you can specify the CCM CIP server for primary authentication. Please note that if the install switch is not input properly to the installation time, you will not be thrown with any error messages at that instance. So you would have to set it up later if there was any issues with that. The manual setup dialog would look like this. So you can either select automatic, where it will go for service discovery. If you have a Cisco IMN present server, you can select the IMN present server and point to the server's IP address or the FQDN or the host name. If you have WebEx Messenger, you can choose that and then provide the necessary input. Or if you only want phone capabilities, you can also give the call manager's host name or FQDN and then register for phone-only services. Some of the important thing to note for the Cisco Jabber client is that the discovery cache never expires. So if you have updated the domain name, or the SRV record needs to be resolved to a different server, or you have updated the FQDN of the servers which the SRV records needs to be resolved to, you would need to clear the cache manually. And it's basically located in the app data of Windows PC, and it goes through the subdirectories of Cisco Unified Communications, Jabber, CSF config, followed by the service location.xml. So you need to erase the service-location.xml file, relaunch the Jabber so that it again runs a discovery service and caches the new information. Please note that for if you are trying to set this up manually, the 9.2 bootstrap file will not be picked up by the later versions, as it is not backward compatible. And you would have to use the install switches to create a new bootstrap file in case you are doing a new deployment and you want to do, instead of service discovery, you want to do it manually for all the clients. So I would pass on the ball to Raees to continue with user discovery service with Expressway Edge.
Thank you, Vasanth. So before we actually dive into the Expressway Edge, role, what UDS plays there, let's look into the UDS logs and see how they look like. So Vasanth, can you make me the presenter? Let me go ahead and share my desktop. You should now be able to see the logs which we have collected from the Jabber client, and it was trying to do the service discovery, right? And we have annotated the logs, and we have removed the extra stuff, so it looks more concentrated version of the logs that we actually collected from Jabber. So what it initially does is it will do a DNS query for _Cisco-UDS @ domain name mangolab.com. And it receives, that DNS SRV record lookup resolves to raees.pub.mangolab.com. So what it will now try to do is it will try to do a UDS servers lookup, right? And it will send a query like this to the FQDN that it received from the DNS SRV, right? And if you see here, I received a certificate prompt. The reason there can be multiple reasons for receiving a certificate prompt. For example, you have your cluster certificates being signed by a CA, and if you don't have that root CA certificate in your laptop or desktop, wherever you're running Jabber client, right? And so initially you will get a certificate prompt. You can also receive certificate prompts in scenarios where the certificate includes the FQDN, whereas here you have the response here only includes either the IP address of the server or just the host name. So the Jabber client is not able to match up the certificate against the host name or the IP address, and then you receive a certificate prompt. The way to resolve this is to add the host name or the IP address in the SAN field of the certificate and reissue the certificates basically. So anyways, once it does a UDS service query, it will send this query to the UDS server, which is what we received from the DNS SRV record lookup. And I go and accept the certificate prompt for now, and this is just the first time. And you don't have to do it all the time, the Jabber logs in anyways. And in the response, we receive the server information. So this is the response that we received from Shaikh pub server, and it mentions the UDS servers in that cluster. So we have the publisher running the UDS, we have the subscriber 1, and then we also have a subscriber 2, which is mentioned using the IP address. So once it receives the UDS server information, the Jabber client will now query for home UDS server information to find the home cluster. And the query would look like this. This is an HTTPS query going out to the first server in the UDS servers list, along with the user Raees here. So it is sending the home UDS request. Once it sends the UDS request, it receives a service profile URI from it finds the home cluster, and then it will get the service profile information, which includes all this. So it tells UCM version, the domain, the publisher. You also receive list of UDS servers, service profile XML, TFTP servers from whom it needs to fetch the file, and the home UDS node. So this is the home UDS cluster information. So once it receives this information, it is now going to contact this server for to get its configuration file. So it is attempting to download from the cached TFTP addresses the jabber-config XML, right? And it will then, once it receives the config file, it will now go and contact each of the servers listed in the service profile, like the TFTP, the IMNP server, the voicemail server, etc.
So Raees, I think the important point here is when the service discovery has identified the home cluster, and then it reaches out to the home cluster for identifying all the services, the different elements that it downloads is the service profile XML file, the list of UDS servers, TFTP servers, and the home UDS node. So if you have any issues with service discovery, the first thing you should be looking at is to identify if the Jabber client is able to download these information from the TFTP server.
Yeah, the other and the easiest way is also to just copy this into your browser and then click enter, and you should be able to see the response. If you don't see the response, which means that there is some problem communicating over HTTPS, etc. All right, so let's go back to the slides now. Vasanth, I'm making you the presenter again. All right, so with the Expressway Edge, the session is more concentrated on the UDS service. So we are not going to do a great in-depth detail of the explanation of the Expressway Edge architecture. However, having said that, we will talk a little bit about the DNS SRV Lookup and also what UDS, how UDS plays its role in the entire architecture of Expressway Edge. Now, coming to DNS SRV Lookup, in the earlier slides where Vasanth mentioned _Cisco -UDS. Now, this is mainly required when the Jabber client is in your enterprise network, right? It will then do a lookup for _Cisco -UDS. Whereas if the Jabber client is located in the public domain, it is going to use the _collab-edge, SRV record, and your public DNS should resolve this to the the Expressway Edge server. All right. But having said that, the Expressway C and all the internal servers should be able to resolve _Cisco -UDS on their internal DNS server. So in other words, the external DNS should be configured to resolve _collab-edge, whereas the internal enterprise DNS should be able to resolve _Cisco -UDS. Please. See the Expressway Edge flow where you have the Jabber client in the other video endpoints in the public domain, which will contact the Expressway E, which is facing the public network. The Expressway E talks to the Expressway C, which is mainly an HTTPS reverse proxy and a SIP proxy as well. The Expressway C will then talk to the communication manager and also the IMN presence server. So in your external network, so once you shoot the Jabber up in your PC or in your iPhone, etc., it will do a DNS record lookup, which will go to _Expressway-edge, and your public DNS should resolve this to your VCS Expressway. Once that is done, the Jabber client will contact the VCS Expressway to find the UDS servers. The VCS Expressway will talk to VCS control, and which will then talk to the communication manager and respond back with the UDS server information. The Jabber Edge will then do a lookup for the home cluster. And once it finds the home cluster, it will then go and try to get the config file and register. So in this scenario, this is a single network element where we have only a single VCS or the Expressway C server, and then we have a single cluster of CUCM and IMN3. Here it is showing you a clustered environment. You can also have a cluster of Expressway C for scalability. You can have a cluster of Expressway E, Expressway C, and a CUCM cluster. And you have Jabber endpoints registering both from within the enterprise, and you also have Jabber endpoints registering over the public network. Change the next slide, please.
Yeah, all right, so the multiple clustered network elements.
All right, thanks. So here you see you have multiple clusters, not just one CUCM cluster, but multiple CUCM clusters. Now the point here to keep in mind is each of your CUCM cluster needs to be configured on your Expressway C server. The reason is once it receives the UDS query, VC is going to do a UDS broadcast. The Expressway C, which is 8.1 and above, have been designed to talk UDS to the communication manager server. So once it receives a query from the Jabber client via Expressway E, the Expressway C or the VCS control is going to do a UDS broadcast, and it will send the broadcast to both the clusters. So here, a scenario like you send the broadcast to SME and SME will send it to all the other clusters is not applicable anymore. You will have to have all your communication manager clusters, configured on your Expressway C or your VCS control servers. I think we are done for today's session, and we have the last question out for you.
Thanks, Raees. So let me read the polling question number 3. The question is, after attending this session, how confident you are in configuring and implementing UDS over ILS network? There are 3 options. Option A, need more help in understanding the concept. Option B, I did understand the concept but need more assistance in configuration. And the last option, option C, I'm confident with the concepts and can easily deploy UDS over IDS. So the poll is open on the right-hand side of the console. Please take a moment. While you are recording the response, all the questions are coming in on the Q&A, and I'm pretty sure Ashish and Sankar, they are busy responding to all the questions. Okay, so thanks Raees and Vasanth. I think it was a great presentation with the demo. And thanks to everyone for participating in the event polling. Now it's time to answer some of the questions our attendees have submitted today. If you can't stay for us for the Q&A, please be sure to click on the evaluation link provided in the chat to let us know how this session met your business needs and expectations. So now it's time to start the Q&A. Okay, so let me take a couple of questions that came in, and you can also pose the questions in the Q&A because experts are on standby. So the first question is, I tried to set up ILS using TLS authentication, but it's taking too long and getting listed in the topology. So Raees and Vasanth, anyone of you would like to answer?
Yeah, I would take this question here. So seems like a very trivial problem here. So when you are setting up a TLS authentication, the first thing that you need to look at is make sure that the certificates are consolidated on a SFTP server, and then you have imported back all the certificates on all the peer clusters. So you can also review if there are any alarms or alerts coming in the RTMT, and there is an alarm catalog for ILS based configuration, and you can review the alarm and take the necessary action. For this case, let's say the TLS authentication is taking too long, would probably indicate that there is a configuration issue in the backend. And the best way to identify this, even before pulling the logs, is just to log into the RTMT and identify the alarm and take the necessary actions, like uploading the certificates and making sure that all the peer clusters are having all the certificates synced up.
Okay, thank you, Vasanth. Another question is, ILS architecture change is in 9x. ILS architecture changes in 9x and 10x.
So if I understand it right, you want to know more about the changes between Communication Manager 9.x and 10.x with respect to ILS. Now, like we mentioned, ILS was primarily designed for URI syncing between different clusters. And in 10.x, we also support the global dial plan replication. Now, for the global dial plan replication, the ILS has to write into the database, and this is only possible from the publisher. That's why in CUCM 10.x onwards, you will have to have your ILS service running in your publisher and up at all times. But having said that, if you're as far as UDS is concerned, it can continue to run even if your underlying ILS network is broken at a later time. I hope that all answers the question. Yeah.
Perfect. Yeah. So there's one more question. Seems like a scenario-based question that says UDS service discovery failing despite ILS being functional. Shall I repeat? UDS service discovery failing despite ILS being functional.
Okay. I'll probably take this one. So UDS basically relies on the list of detected remote ILS clusters, which is displayed in the advanced cluster overview. So UDS periodically checks this table for all the detected remote ILS clusters and then access the UDS resources on these clusters to find out about the UDS nodes in the remote cluster. Hence, the service discovery does not really rely on ILS. These are UDS transactions which is very persistent. So the first thing that you would need to do is identify the nodes which are running the UDS and validate by running the user query using the web browser for identifying the home cluster of the user, and then you can further check if the user is able to identify the services that he has been subscribed to. I hope that helps here.
Okay, thanks, Vasanth. The next question is, will UDS work if ILS is non-functional?
Yeah, I think like I mentioned before, once the ILS network is set up and you have UDS services being able to authenticate and talk to each other, if the ILS goes down at a later point in time, the UDS can still continue to work.
Okay, there is another question that says, how does UDS redundancy work?
So, well, the redundancy for UDS basically works based on the DNS SRV implementation. So, if the DNS SRV records returns the publisher's IP address, it will try to query the publisher and try to find the user's home cluster and so on and so forth. And if the publisher is down, it will, depending upon the SRV record implementation, if you have alternate servers configured, the request will go to the corresponding server.
Okay, thanks, Vasanth. So there is a question that says, data learned from ILS lost when the publisher is down. Another scenario question. Data learned from ILS lost when the publisher is down.
Okay, I think I'll take that. So if the ILS setup is down, the data is not lost. It is always there in your database. But then, if there are any changes, so for that changes to replicate, you need to have your ILS working at all times. So it is not a good scenario when your ILS is not working, because the changes will not get replicated between clusters. So to answer your question, yes, the data will still be there, but it is always good to have the ILS running.
Thanks, Raees. So let me take one more question. The question is, I cannot find utils find X node in CUCM 10X. I'll repeat, I cannot find utils find X node in CUCM 10.x.
Okay, I'll probably take this one. So in 10.x onwards, the Intercluster Lookup Service only runs on publisher. So the whole concept of X node was to determine which server would be interfacing with the peer hub clusters or the spoke clusters. But with 10.x onwards, with that dependency gone of subscriber running the ILS service, and only the publisher is going to exchange the information via ILS. So another thing to note here is, without the publisher server, ILS will fail to establish connection with the hub and spoke nodes. The primary reason to bring the ILS service dependency on publisher is because with 10.x we have introduced a global dial plan replication between the clusters part of the ILS network, and updating the global dial plan replication would need an update in the Cisco publishers database. So without having publisher reachable, you will not be able to perform those transactions, and thus there is no xnode command, and there is a dependency on the publisher for ILS to work.
Okay, thanks, Vasanth. So that concludes the Q&A portion of today's event. So just want to tell you, Raees and Vasanth are also hosting an Ask the Expert discussion that will continue till July 6th, that is for 2 weeks. The link has been posted in the chat window, so you can continue asking questions on the same topic. Raees and Vasanth will be responding for next 2 weeks. If you have additional questions, please log into Cisco Support Committee and go to Expert Corner. You can find a lot of discussions in the knowledge sharing section, or you can click on the link as I provided in the chat. Okay, so it's time for the trivia question. You might have seen on the banner ad of this webcast. The question is, what do Intercluster Lookup Service and one of the world's biggest advertising agencies have in common? So there are 3 options. So take your time. The question is open in the poll window. Okay, so while you're responding, so these are some of the upcoming events. The June Ask the Expert event in Portuguese, if you speak this language. The topic will be VPN configuring and troubleshooting. It will take place on June 4th, 11 a.m. Brasilia time, which is equivalent to 10 a.m. New York City time. Our expert will be talking about the basic concepts used for implementing Get VPN and its configuration and verification. The link is in the slide, also will be posted in the chat window. And the next English webcast happening in June. The topic is integrating Cisco Cloud Security and Adaptive Security Appliance, ASA. It will happen on Tuesday, June 4th, 9 a.m. Pacific time. During this event, our subject matter experts, Jennifer and May, will explain how to integrate Cloud Web Security, CWS, and ASA. So the registration link is available again in the chat window, also on the slide, and you can register for free. And these are some of the Ask the Expert events which are currently live. If you have any question on these topics, you can go to knowledge sharing in community and then ask the questions. The first topic is Cisco Nexus Architecture Designs, hosted by Ahmed, and this ends on June 6th. The second topic, which is currently live, the Ask the Expert. The topic is Troubleshooting Cisco UCS and Fiber Channel Storage by Ali and Jalpa. This will also end on June 6th. And these are some of the Ask the Expert events upcoming, which starts on June 9th. The first, the topic is Planning and Designing and Implementing Mobile Remote Access, Collaboration Edge by Ashish and Abhijit. And the second topic, which will again start on June 23rd, the topic is Introduction to iOS XR, and this will be hosted by Anil Kumar Dantu, and he will, you can ask questions on basic fundamental difference between iOS and iOS XR, how iOS XR as operating system is packaged, boot up procedure in iOS XR, basic config and config file system, difference between iOS and iOS XR. Okay, so if you haven't already logged into the Cisco support community recently, we encourage you to do so. We have a brand new look and feel, so log in and start sharing today. And this is where you can share current real and real world technical support knowledge with your peers and experts. And be sure to check out the class of 2014 events top contributors. Some of them are external, some of them are internal from Cisco. If you are interested in conducting an event for us and becoming a top event contributor yourself, please go to the Expert Bureau and sign up for it. Our presence in social media and iTunes keep expanding. So we encourage you to visit the community and join us through these social media channels. The links are there in the slide. Also, when you log into the community, on the top right corner, you'll see all these links available. As you saw from our upcoming webcasts in different languages, we continue to expand our reach in many different languages. We have also recently launched our Chinese community, so please be sure to stop by and browse through if you speak Chinese. And take a moment to rate the content of your other documents created by your peers, videos and blogs. By doing so, you will help us recognize the wonderful content that they have contributed. Okay, so it's now time to answer the trivia question that we have asked. What do Intercluster Lookup Service and one of the world's biggest advertising agencies have in common? So I see 50% of the attendees have got it correct. Yes, the option is C. Ogilvy and Mather, one of the world's largest advertising companies, use Intercluster Lookup Service via their usage of Cisco Unified Communication Manager 7 ILS. Okay, so before signing off, please take a few minutes to complete your evaluation of today's session. This will help us address your business needs and interests in the future. And this concludes our today's session. Thanks to our experts, Raees, Shaikh, and Vasanth Kumar for sharing their expertise with us today. And also thanks to our expert panelists, Ashish Dua and Sankar Voleti, for answering your technical questions. Thank you and have a wonderful day.
Thank you all.